Chapter 10, the mole, Section 3, moles of compounds. Objectives. Recognize the mole relationship shown by a chemical formula, calculate the molar mass of a compound, convert between the number of moles and the mass of a compound, apply conversion factors to determine the number of atoms or ions in a known mass of a compound. Representative particle, an atom, molecule, formula unit, or ion. Remember when we talk these are the units of 6.02 times 10 to the 23rd. It can be a particle, it can be an atom, it can be a molecule, formula unit, ion. Remember those are interchangeable. Oops, let's go back here. The main idea for this section, the molar mass of a compound can be calculated from its chemical formula and can be used to convert from mass to moles of that compound. Chemical formulas indicate the number of types of atoms contained in 1 unit of the compound. So if we have 1 mole of CCl2F2, we have 1 atom of chlorine, 1 atom of carbon, 2 atoms of chlorine, and 2 atoms of fluorine. The molar mass of a compound equals the molar mass of each element multiplied by the moles of that element in a chemical formula and then all added together. The molar mass of a compound demonstrates the law of the conservation of mass. Converting moles of a compound to mass. For elements, the conversion factor is the molar mass of the compound. The procedure is the same for the compound, except that you must first calculate the molar mass of that compound. Converting the mass of a compound. The conversion factor is the inverse of the molar mass of the compound. Okay, so here's your example. If we have 5.5 grams of the compound, how many moles do we have? So you have 5.5. What you're given always goes on the left-hand side, and then you use your mole to grams ratio. Notice that your grams of compound can cancel out. Your units that are left are what you're looking for, moles of compound, and then you do the math. So you're going to take 5.5 divided by 185.0, and that'll give you 0.0297 moles of compound. Converting the mass of a compound to number of particles. Convert the mass to moles of compound with the inverse of the molar mass. Convert moles of the particle with Avogadro's number. Okay. This figure, you've kind of seen something similar to this before, but this is a really good one to help you know where you're starting from and where you're going. So if you're given moles of compound and you want mass of compounds, you're going to follow this arrow, and this is the conversion factor you're going to use. If you're given mass of compound and you want moles of compound, this is the conversion factor you're going to use. So look at what you're given in the problem and what they want you to find, and that'll help you with the conversion factors. Practice, practice, practice. How many moles of OH minus ions are in 2.50 moles of CaOH2? Answer is 5.0. Remember, you're going to put, this is what you're given, this is going to go on the left-hand side. You're going to use your conversion factor and find your answer. How many particles of magnesium are in 10 moles of MgBr2? Particles, again, remember particles. What you're given goes on the left-hand side. You know you want particles, so you're going to have to use a 6.02 times 10 to the 23rd particles per mole. And your answer is 6.02 times 10 to the 24th. Once again, practice, practice, practice.